Okay, Assalamualaikum guys, we from DMF. Today, our group we solve a problem for tutorial for B, for question 8.10. So the questions give the minecar and its content have total mass of 6 mg and center gravity at G. If the coefficient of static friction between the wheels and the track is newtons s equal to 0.4 when the wheels are locked, find the normal force acting on the front wheels at B and the rear wheels at A when the brakes at both A and B are locked. Does the car move? So the question want to us find the normal force. So you guys know that nu s is equal to nu static, which means that the object does not move and it's static on the plane. Okay, this is the diagram that the question showed. So he gives force, distance, width, and the normal force. Okay, first steps to find the normal force that acting at the rear B and rear A. We must find the weight first. So the weight equal to mg, and so the mass as given at the question, that the mass state is 6 mg. Okay, so we put the mass 6 times by 9.1, that which called gravity, equal to 58.86. Okay, and then we must solve the normal force at A and normal force at B. Okay, to solve the normal force at A and normal force at B, we have to use moment. Okay, so moment equal to 0. Okay, we must define the moment is counterclockwise or clockwise. So to define that the moment counter or clockwise, okay, look at the mine. So the force move left side towards left side us. So when the force move left side, the rear will rotate counterclockwise. Okay, that means positive. Okay, so we state that NA, which is this normal force at A, times by 1.5, which is we took the two normal force at A and B, which is distance, it gives 1.5. So we times by 1.5 meter plus 10 times by 1.05. Okay, this is 10 kilonewton, this one, and the 1.05 meter, we got that 0.9 plus 0.15, because when the force we pull left side, the wheel B and the wheel A will move too. So we must calculate this, we must add these two distance. Okay, and then we minus 58.86. Okay, why minus? Because the weight move downward, and we times by 0.6 meter. 0.6 meter is at this one. Okay, and then we use the simple maths to get the NA. So the NA is equal to 16.544 kilonewton. Okay, the next step, we use the y-axis. Okay, so y-axis equal to 0. Then NA plus NB minus 58.86 equal to 0. We got that NA is equal to 60.554. So plus NB equal to 58.86. And the NB we got that 42.3 kilonewton. Okay, the next step, for the friction, we must use the formula force max to got the true friction. Okay, so the force max at A, we use the formula Newt times by normal force. Okay, so Newt A 0.4, which is from the question, it states that Newt static equal to 0.4. Okay, 0.4 minus by the normal force at A, we got that 6.6176 kN. And then we do the same things for the force max at rear B. So we get that 16.92 kN. Okay, and then we add up the force max at A and the force max at B. So we got that 23.53 Newton. And then we state that the force at the wheel B and A is bigger than the force we pull. So that's why we use this symbol. Okay, so the wheel did not slip and the mine car did not move because the force that we pull is lower than the force at the wheel B and A. So the mine car did not move. Okay, that's all from us. Thank you.